Today, I am going to teach you about biostatistics. It is one of the most important topic of community dentistry. Biostatistics is the term used when tools of statistics are applied from the data that is derived from biological sciences such as medicine. Here we are talking about statistics. Statistics is basically science of figures like we can collect data about human being. Here we are not talking about any like non-living things. Here we are talking about collection of data of living individual. Like we can collect data in the form of any figures. Biostatistics is a field of study concerned with techniques or methods of collection of data. Here we can collect data like say example, we want to know about status of fluorosis in an area. Here firstly we will describe the place where fluorosis is prevalent, and we can describe the time, like we can describe time in the form of year or any instantaneous time, and person. First like say example, we want to know about the status of fluorosis in some area of Bihar in the year 2022, and the person can be the age group like from 4 to 10. This is an example only, 4 to 10 years of age. Here we have described place, time and person. Now we have collected data like from 4 to 10 years of age. Fluorosis in Bihar are present in near about 4,000 example, like 4,000 individuals. So we have collected data. We have collected live data, that the data is about human being. Here we are not talking about any non-living things, and we have summarizes that in some Buxar district of Bihar. We can talk about more specifically about some district, about some village, etc. And we have interpreted that fluorosis is more prevalent among 4 to 10 years of age, and we have drawn a hypothesis over here that fluorosis is prevalent in Buxar district of Bihar, where the content of fluoride in water is more than 1 ppm, that is parts per million. So the sources of data can be any experiments, can be survey, or any records. Records can be present in any hospital, NGOs, etc. We can we can do any experiments related to any hypothesis, like fluorosis is prevalent in Buxar districts of Bihar. This is our hypothesis, and we will do some experiment to prove that the fluorosis is literally prevalent in that area. Now more about nominal and ordinal scale. Earlier I have talked about we have classified data on the basis of variables that are used to categorize the data. Like it seems difficult now, but I'll try my best to explain it. We have talked about different variables are used for categorizing the data. Like we have collected any data and we have classified data based on the variables, and variables of data are measured on nominal and ordinal scale. Now nominal scale, here we are talking about qualitative data only. Both nominal and ordinal scales are used to categorize the qualitative data only. So the variables over here, we take qualitative variables only. In both nominal and ordinal scale, we use qualitative variables, and these are the types of qualitative data. Here we are not talking about quantity like 1, 2, 3, 150 centimeter, 170 centimeters. We are not talking about quantity. Here we are talking about quality. Qualitative data are classified on nominal and ordinal scales. On both the nominal and ordinal scales, we classify qualitative data, and indirectly we can say that the qualitative variables are used to measure nominal and ordinal data. Like nominal scales, for example, we deal about presence or absence of any disease like fluorosis or dental caries. Here we are just naming it, like whether the fluorosis is present or absent in an individual, or whether the dental caries is present or absent in an individual. Here we are just naming the gender, like whether the person is male or female, and we are just saying that whether the person is vaccinated or non-vaccinated. And we are not talking about how many times person is vaccinated, we are just saying the person is vaccinated or not. Here more example, like whether the person is diabetic or non-diabetic, whether the person is having tumor or tumor is absent in that person. Now ordinal scales, here the variables are ordered on a scale. Like here in nominal scale we have just named the variable, and in ordinal scale we are just classifying the data in some order. Like here we have talked about whether the fluorosis is present or absent in an individual. Now we'll talk about the status of fluorosis in ordinal scale. Like the status of fluorosis can be very mild, moderate or severe. Here in nominal scale we have just named it whether the person is having tumor or not, and in ordinal scale we will grade the tumor, whether the tumor is mild, moderate or severe. Some more example of ordinal scale is height of a person, like whether the person is short, medium or tall. We are not mentioning the height in centimeters or meters, we are just saying whether the person is short, medium or tall. Now I'll be teaching you about quantitative data. Quantitative data are those data in which we deal about quantitative variables. Like variables over here are quantitative. Here we deal about quantitative variable, like those variable which can be measured and we can also put some unit into it like millimeter, centimeter, height, weight, like kgs, etc. Now there are 5 types of quantitative or continuous data in which we talk about continuous variable. The 5 types of quantitative data are histogram, frequency curve, line chart or graph, cumulative frequency diagram or ogive, and scatter or dot diagram. Now in histogram, like we want to know about the size of the inflammatory reaction that has occurred due to tuberculosis. Like we have gathered some person and we want to know about the tuberculin reaction among those people. Like we can give vaccine to those people and we want to know the size of the inflammatory reaction among those person. Like the size of the inflammatory reaction due to tuberculin injection could be 8 millimeter, it could be like 8 millimeter, like 10 millimeter, and 12 millimeter, etc. So we want to know about the size of the inflammatory reaction that has happened due to tuberculosis. And here the frequency is continuous, and we have some angulation over here. And in frequency curve, we want to measure data in a large number of population. The difference between the histogram and frequency curve is that here the number of individuals are less individual, and here the number of individual, a large group of population. Here the group of population is large. In frequency curve, the group of population is very large. Here I can give you the example, like we want to know the size of tumor in centimeter. Like the size of the tumor could be 1 centimeter, 2 centimeter, and we want to know the relative frequency of the size of the tumor. And here we have taken the large group of population, so the curve here is not angulated, here the curve is straight. So the curve is angulated in histogram and the curve is straight in frequency curve. Now line chart or graph, here we have shown the advancement of population with the advancement of time. Here with the advancement of time, that is year, the population of any country increases. It shows the trends of events. Events could be like any death or disease, or it could be like any event. So we have shown the advancement of population with the advancement of age in this graph. Like in the year 1901, the population of a country was 300 million, and with the advancement of 1921, the population of a country reaches the 500 million. So the population of a country is increasing, so it is showing increasing trend. And now the cumulative frequency diagram or ogive, here we satisfy the two variables on the same graph. Like we have taken height in centimeter on the x-axis, and we have shown the cumulative frequency on the y-axis. Like and we have taken over here like the weight of a person, like the height and weight of a person is increasing over here with the advancement of age. So we have satisfied over here two variables, that is the height and weight of a person is increases with the advancement of age. cumulative frequency diagram is also known as OGIF. Now the scatter or dot diagram, here we have satisfied the relation between two variables, like here we are talking about the quantitative or continuous data. Like in a scatter diagram, we can say that with the advancement of height, the weight of a person increases, or with the advancement of height, the weight of a person increases. With the advancement of height, the weight of a person increases with age, and it is not always 100% sure, so we have not put it on the straight line and we have shown it via scatter diagram. So we can say that the height or weight of a person increases with the advancement of age. Now I'll be talking about qualitative or discrete data. Qualitative or discrete data cannot be measured directly, it is measured on nominal scale. Qualitative or discrete data are measured on nominal scale. Here we can just name the data, we don't put any quantity, continuous quantity like 1, 2, 3 or 150 centimeters or kgs, 155 kgs, etc. We don't put any numerical value to this data, we just name the data. Like there are several examples of qualitative data. Bar diagram is one of the most common example of qualitative or discrete data. Here we have measured the percentage of population admitted in a hospital, and here the bar diagram is not continuous. Like I have told you, in quantitative data the variables were like continuous, and here the variables are not continuous. Like it was the example of qualitative data, so that we can distinguish between the qualitative and the quantitative data. Here the variables were continuous and here the variables are discrete, and we are not measuring magnitude over here, we are just naming, like we are just saying the percentage of population of the age 0 to 5 years are admitted in the population are 12%. Likewise, pie or sector diagram, we measure the variable in degrees. Like we can measure the degree of fluorosis over here. Like fluorosis could be mild, moderate or severe. We are not putting over here like the size of fluorosis 0.5 centimeter or any other centimeter. We are just saying whether the fluorosis is mild, moderate or severe. Here the variables are being divided by 100. And in pictogram, we represent data with the help of pictures. Like we can show here the prevalence of fluorosis in any area. Like the prevalence of fluorosis over here is less in that area, and it is showing increasing trend over here, and it is showing decreasing trend of the fluorosis. With the adaptation of fluoride in the toothpaste, the prevalence of fluorosis decreases. So we have shown here with the help of diagram. Now I'll be talking about the map or spot diagram. Here I can show you the cases of COVID in the year 2022 in India. It was like more in South India, and it is less in the region of we can say that this is north, south, east and west. So we can show the prevalence of any disease in north, west, south and east direction of India. Now I'll be talking about the Venn diagram. In it I'll be showing that the prevalence of dental caries is only possible when there is agreement of agent, host and the environment.